Okay guys, once again welcome back. In today's video I'm going to solve question 9 from November 2020. Okay, the question is focused on optimization problem. You can see optimization problem. So this is question 9. You have it there. It's question 9 from November 2020. Okay, so you have two questions to solve, 9.1 and 9.2. Okay, let's get started. Okay, question 9 on optimization problems from November 2020. Let me get the question again. Question 9. Okay, so this is the question that you have. I hope you can see it. Okay, so the question is, question 9, a closed rectangular box has to be constructed as follows. You have the dimensions, the length, the width, and the height. The length of the base has to be 3 times its width. The volume has to be 5 cubic meters. Okay. The material for the top and the bottom part cost 15 rand per square meter, and the material for the side cost 6 rand per square meter. I hope you can follow as I read the question. 9.1 show that the cost to construct the box can be calculated by this. The question is 4 marks. And we have 9.2, determine the width of the box such that the cost to build the box is a minimum. The question is 6 marks. In total, 10 marks for question 9. Okay, question 9.1. Okay, let's get the information down first. I hope you have the idea of what a rectangular box looks like. Okay, let's have the shape. So this is the shape. This is a rectangular box. So it's closed at the top. So because they say a closed rectangular box, so the shape is like this. You have the dimension there, the length, the width, and the height. Okay, so you have the length, and you have the width and the height. Okay, so according to the information you are given, when you read here, it says the length of the base has to be 3 times its width. Okay, so the length is equal to 3 times the width. Okay, I hope you can see that, 3 times the width. So these are the dimensions of the rectangular box, the length, the width, and the height. Okay, and you are also told that the volume has to be 5 cubic meters. Okay, let's write that information down. The volume is equal to 5 cubic meters. Okay, now when you read this part, the material for the top and the bottom part cost 15 rand per square meter. Okay, let's write this information down. So the top and the bottom part, the material to construct the top and the bottom part cost 15 rand per square meter. Okay, and now the side part cost 6 rand per square meters. Let's write that down. So the side part, you will need 6 rand per square meter to construct the side part. I hope you can see that in the shape. This is the bottom part, you can see there, and this is the top part. The side part, we have this in front, and the one at the back, we have this at the right, and the one at the left. Okay, so the side part are 1, 2, 3, 4. The bottom part and the top part, this one and this one. I hope you can see that. Okay, so the question is to show that the cost to construct what the box can be calculated by this. Okay, so in order to know the cost, we'll need what? To know the area of the top and the bottom part and the area of the side part, because the price as they are given, you have 15 rand, which is the price of 1 square meter for the top and the bottom part materials, and we have 6 rand, that is the price of 1 square meter for the materials for the side part. Okay, so what you need to know is to find out first the area of the top and the bottom part and the area of the side part. So in other words, you need to find what? The total surface area of this box. When you open it up, you'll see that you have 6 parts in total. I hope you can see that. You will have 6 parts in total. You have the part at the bottom plus the part at the top. That is 2. And you have this in front and the one at the back. You have this at the right and the one at the left. So you have 4 plus 2, which is 6 parts in total. Okay, but you have the material to construct the top and the bottom part. They have a different price from the material to construct the side part. Okay, you can see that. So let's find the area of the top and the bottom part separately from the area of the side part, and then we are going to add that to find what? The total surface area. Okay, so let's do this. Let's close this for now. So this is the information you are given, right? So in the exam, maybe you don't need to write this information down, but personally, I like to write down the information so that I can follow along as I solve the question. Okay, maybe for you, you can start from the next step from here, what I'm going to write down now. So let's start with the area of top and the bottom part. So this and that. Okay, you can see this is a rectangle and this is also a rectangle. So the top and the bottom part, they are similar in shape. These are rectangle. I hope you know how to find the area of a rectangle. Okay, so according to what you are given here, with what you have here, to find the area of the bottom part, it will be the length times the width. Remember, this is a rectangle. I hope you know that. I hope you know how to find the area of a rectangle. It will be the length times the width. Okay, so the area is equal to the length times the width, like that. Okay, so you have what? 2 of them, the top and the bottom, they are similar in shape. So you are going to do what? To multiply by 2, like that. You can see. So you have this part at the bottom and the part at the top. Okay, so and then you carry on. The area is equal to 2 times this. Can you see from the information the length is equal to 3 times the width? Let's replace the length with 3w, because the information tells you that the length is equal to 3 times the width. Okay, so I replace my L with 3w, and then again this is times that w. Okay, you close your bracket and you carry on. The area is equal to, this will give you 6, so it's 6w square. You can see w times w, so the width times the width is square. You have 2 times 3, it's 6. Okay, and remember the units are square meter. Maybe you don't need to put the units down. Okay, if the question is not asking you to put the unit, but let's put the unit. You know the unit for area are what? Square meters, because we are using meters in this question. Okay, so the unit for area will be square meters. Now we have the area what? The area of the top and the bottom part. Now let's find the area of the side part. Okay, so now you have to be careful here. You can see the side part, the one in front and the one at the back, they are similar in shape, unlike the one at the right and the one at the left. So the one at the right and the one at the left, you can see this is the one at the left. Can you see? This is the one at the left and this is the one at the right. They are similar in shape. You can see the one in front and the one at the back, they are similar in shape. Okay, let's start with the one in the front. So to find the area of the side part, this is also a rectangle. You take this side times this side. So this side is called the height and this side is called the length. Because this is the rectangle, it will be length, right, times the height. It's a rectangle, so it times h, like that. And remember again, you have two of them which are of the same shape. So the one in front and the one at the back. So you must have what? 2 there. You multiply by 2. So you are done taking the area of the part in front and the part at the back. Now, this is equal to this plus. Now you have this part at the right and the one at the left, because you are trying to take what? The area of the side part. You have 4 of them. Can you see when you go around, you have 4 of them. So now, let's start from the one, we can start with the one at the right. So this is also a rectangle, you can see. So it will be this side times this side. This side is known as the width, and this is known as what? The height. You can see this is the height, and this is also the height, and this is also the height, and this is also the height. So this is a rectangle. To take the area, you have the width times what? The height. So it's the width times the height, right? And remember again, you have two of them which are of the same shape. So you have this one at the right and the one at the left, they are of the same shape. So you have to put times 2. You multiply everything by 2. So I have 2 there, okay? And so you carry on. The area of side part is equal to, you have 2 times, remember again, L, the length, is 3 times the width. So let's replace the length or L with 3W, right? Times, you can see H, 10 plus 2, you have W times H. I hope you can follow that. So this is L being replaced with 3W, because in the information you are told that the length is equal to 3 times the width, okay? So you carry on. The area is equal to 2 times 3, which is 6WH, okay? The width times the height, plus 2 times WH, so it's 2WH, the width times the height. And this is equal to, can you see you have 6WH, 2WH. They are similar, like terms. So this will give you 8WH. You can see that. Okay. So now you have the area of the top and the bottom part. You also have the area of the side part. Remember again, if you want, you can put the unit. So the units are square meters, because this is the area. Okay. So from here, now you have what? The total surface area. Can we get that? The total surface area will be this one plus this one. Okay, so the total surface area is equal to this one, I have it, plus this one. I hope you can follow. Can you see? So this one plus this one. So you don't have like terms. Okay, you just leave it like this. So this is the total surface area of this rectangular box. Now, when you know the area that you have, you can now use the price that you are given to find the cost. You are told that the material to construct the top and bottom part will cost you 15 rand for 1 square meter. And the material to construct the side part will cost you 6 rand for 1 square meter. Okay? I hope you can see that. So let's find the cost. So from here you can see this is the total surface area. Remember, this is from the top and the bottom, and this one is from the side part. Okay, so the side part, it's 6 rand for 1 square meter, and the top and bottom part, it's 15 rand for 1 square meter. Okay, so the cost is equal to, this is for what? This is for top and bottom. Top and bottom cost you 15 rand for 1 square meter. But we have this amount of square meter. So to find the total cost, it will be 15 times this. So we have 6W square this you multiply it by 15, because this is top and bottom, it costs you 15 rand. And you can see top and bottom, the area is this one, so you multiply by 15, and then plus. Now this is the area for the side part, 8 WH. Okay, so for the side part, it costs you 6 rand for 1 square meter, but we have this amount of area for the south part. To find the total cost, you multiply by 6. Okay, like that. And so the cost is equal to, when you multiply 15 times 6, it will be 90. Then W square plus 6 times 8, it's 48. You have WH. Okay, I hope you can see that. Did we found what was in the question? Let's see. Question 9. The question was, show that the cost to construct the box can be calculated by this. Can you see this is what we found? 90W square plus 48WH plus 48WH. Okay, and it's 4 marks, just like that. You collect the marks. Okay, let's move on to the next question, question 9.2. Now 9.2, let me get the question again. It's question 9 from November 2020. This is the question. Now this question says 9.2, determine the width of the box such that the cost to build the box is a minimum. 6 marks. Let me read the question again. Determine the width of the box such that the cost to build the box is a minimum. Okay, this is the box. We still have the same box. You remember it from the previous question. And we are interested in what? In finding the width such that the cost to build the box is a minimum. Okay, so the cost is this. Remember from the previous question, this is the cost that we found. Okay, so the problem here is to determine what the width such that the cost is a minimum. But in this, if you can check, you have two variables. You have the width and you also have the height. Can you see the width there and the height? But let's change this. Let's have only the width inside this formula, and then we can now solve for what? We can now determine the width such that the cost to build the box is a minimum. Okay, we have to find what is h in terms of the width, I think. Okay, so when you read, you are given this information, the volume has to be 5 cubic meters. You can use this information to solve for the height, h, and then you're going to have the width everywhere. Okay, so remember the formula to find the volume of this rectangular box. I hope you know how to find the volume. It will be the length times the width times the height. Okay, so the length times the width times the height. This is the volume for the rectangular box. This is the rectangular prism. I hope you know that. And this is equal to what? According to the information, this is equal to 5. When you read here, the volume has to be 5 cubic meters. And this is the formula for the volume of what? A rectangular box or a rectangular prism. You have to know this. I hope you know this. By grade 12, you should know this. So the volume is the length times the width times the height. So this is the volume of a rectangular prism. And this is the rectangular prism. Okay. And in the information, you are told that this is equal to 5. And now remember again, you can replace your length with 3W or 3 times the width, because you were told here the length of the base has to be 3 times its width. Okay, let me replace this. So this is 3W, and then again you have times this times the height, and this is equal to 5. Okay, so this is my length. I have replaced it with 3W or 3 times the width, because the information says so in there. And when you carry on, this is 3, this is W squared, W times W, so it's W squared H, right, times H. This is equal to 5. And from here, can you see that you can solve for the height for h and plug it inside there? Can you see you can solve for the height by dividing by 3w square on both sides? Can you see that? I want to remain with only h this side. And this is going to cancel with this. And then you have the height, which is equal to this. I hope you can see that. Let me close this. Okay, so now you have the height. You can see you can take this and plug inside there. So you are going to have only one variable, which is w, the width, because the question is to find the width that will give us a cost being minimum. I hope you get that. Okay, so let's plug the height or h inside there. So the cost is equal to 90w square plus 48w times the height. Let's replace the height with what we found. Okay, this is what we found. I hope you can see that. And you carry on, the cost is equal to this 90w square plus, when you take this 48 times 5, it will give you 240, and then we have w there, so it will be 240w. This is over this 3w square. Okay, I hope you can see that. And you can carry on to make this simpler. So the cost is equal to 90w square plus, can you see 240, you divide by 3, this will give you 80. And then you have w over w square. When the bases are the same, according to the law of exponent, so this will be w to the power of 1 minus 2. Remember, there is a power of 1 there. So you subtract your exponent when the bases are the same, and this is division. So this is according to the law of exponent. So it will be w to the power of 1 minus 2. This will give you minus 1, like that. I hope you can see that. And now, this is the cost. We only have one variable inside there, the width. Can you see? The question is to find the width that will give us the cost being minimum. Okay, let me carry over here. Let me put a line there. Okay, to find the width that will give us a minimum cost, you have to take the derivative of the cost. So it will be cost prime with respect to the width. Can you see? Cost dash there with respect to the width. I know from here you can now find the width that will give you a minimum cost. You have to take the derivative of the cost and you make it equal to 0 and you solve for the width. Let's do that. So I hope you know your calculus. Now let's take the derivative of the cost. So it will be that exponent times that coefficient. You have 90 there. The coefficient is 90. So it's 2 times 90, which is 180. And then w, or the width, to the power of 2 minus 1. So you subtract 1 from the exponent. So 2 minus 1, it's 1. So you have this. And then again, you have that exponent. You multiply it by the coefficient. The coefficient is 80. So 80 times negative 1, it will be negative 80. And then w, or the width, to the power of, you have the exponent there, negative 1. And then again, you subtract 1 to the exponent. So it will be negative 1, negative 1. Or minus 1, which will be minus 2. So this is according to the rules of differentiation. I hope you understand that. Okay. Now from here, what we have to do is to take this, make it equal to 0 and solve for the width. And this will be the width that will give us the cost being minimum. Okay. So let's take this, what we have there. You make it equal to 0. And from here, you solve for the width. You can see you have this. You can bring this to the denominator. Okay, let's do that. So this is this minus 80 over, when you bring this to the denominator, because you have what, negative 2 there as a power, it's going to be w to the power of 2. So it's no longer negative 2, now it's positive 2 when you bring it down when you bring it down to the denominator. Okay, and this is equal to 0. Okay, now we want to get rid of this w squared. What can you do? If you want to get rid of this denominator, what you can do is to multiply by w squared throughout. You multiply throughout. So you multiply this part by w squared, you can see, and you also multiply this by w squared, you can see, and you also multiply this by w squared. So the purpose is to get rid of this w squared. Okay, and now from here you can see this and this cancels. Okay, and you end up with 180 times this, which is w cubed, you can see, minus, you only have 80 there because this cancels. This is equal to, this gives you 0. And you carry on, this is 180 w cubed is equal to, you bring negative 80 to the other side, it's 80. And you want to remain with what? W cubed. You divide by 180 on both sides, like this, so that you can remain only with w cubed. Okay, and so this and this will cancel. You only have w cubed, which is equal to 80 over 180. Okay, you can simplify, but let's leave it like this. We want to find what? W only, not w cubed. What can you do? You take the cube root on both sides. So since it's w cubed, you take the cube root like that, and you do the same on the right side, so that you can remain with w only. There, can you see? Because it's cubed and to the power of cube there, so it will be w, which is equal to, and now what is the answer here? Let's use our calculator. Okay, you can use your calculator as you follow along. Okay, so this is the calculator. Let's do this. So you take the cube root. Where is the cube root? Can you see the cube root there? So you press shift. Can you see cube root? Then you have 80 over. Can you see that this is equal to 0.76. If we can keep it to 2 decimal places, 0.76. Okay, so this is the width, and the units are meters. You can put the unit if you want to, but I believe you have to put the unit always. Okay, so this is the width that will give us a minimum cost. Okay, so and the question is solved. We are done with question 9 from November 2020. Okay, if you'd like to see me make other videos on other topics, please let me know in the comment section. And if you find value in the videos that I'm making, please do not forget to like the video, subscribe to the channel, and activate the notification bell so that you can be notified when I post new content every time. Until next time, I'll talk to you soon.